In this video, we'll talk about evaluating definite integrals of even and odd functions. So I first want to recall that an odd function, formula-wise, this needs to satisfy f of negative x equals negative f of x for all x values in the domain. Okay, so if I draw a picture of an odd function, I'm going to draw my axes. And an odd function, recall, needs to be symmetric about the origin. So whatever it looks like on one side of the origin, it needs to reflect all of those points across the origin. So if we reflect this whole thing across the origin, we'd get something like this. Okay, so this is symmetric about the origin. With an even function, formula-wise, that satisfies g of negative x needs to be the same as g of x. So graphically, if I draw some axes, an even function graph also has some symmetry, but this is going to be symmetric about the y-axis. So whatever our graph looks like on one side of the y-axis, so maybe it looks like this, and it goes up, and then it goes down, it's got to be the mirror image of that across the y-axis. So on this side, it's also going to go down, and then up, and then down like that. So all right, so what I want to do is with each of these types of functions, I want to look at a very specific type of definite integral. I want to look at what happens if you integrate from negative a to positive a. Okay, so for an odd function, if I integrate from negative a to positive a, f of x dx, and our function f of x is an odd function, well, what happens? So if I look at my picture, we're talking about this region and this region, and if I shade these in, here's this region over here, I'm going to shade it in gray. The part that's below the x-axis, I'm going to shade it in red. But because of the symmetry of this picture, this region with this positive area is exactly the same as the region with this negative area. They're just exact opposites. And because of that, this whole integral will just be 0, because these areas cancel out. Okay, if I do the same thing with my even function, if I integrate from negative something to positive something, let me draw in that region. So on the right side of the y-axis, I'd have something like this. But on the left side of the y-axis, we'd have this region. And this time, these are exactly the same, and they have the exact same sign. In my picture, they're both positive. Okay, so if we were to do the integral from negative a to positive a of an even function, g of x dx, so g of x is going to be an even function. So in general, well, it won't be 0 anymore, but what I can say is, this is going to be the same as if I were to do just the integral from 0 to a of g of x dx, but then multiply it by 2, because I get the exact same area on either side. So I just have to do the area from 0 to a and then double it. All right, so I want to look at an example. So we have this integral from -1 to +1 of x ln of 1 plus x squared times e to the negative x to the 6th dx. Okay, so this whole thing in the integral, let me start off by calling it f of x. And I notice that I have an integral that goes from negative something to the positive version of something, -1 to +1. So I might think, maybe this is an even or odd function. Maybe that'll help me. Okay, so I'm going to try plugging in negative x into our function. So this x becomes a negative x, and then we'll get times ln of 1 plus negative x being squared, and then times e to the negative, and then I'll get negative x being raised to the 6th power. So the 6th power. Okay, so if we simplify this, we'll get negative x ln of 1 plus negative x being squared will just be x squared, because when you square that negative, it becomes positive. And then I'll get e to the negative, and then again, negative x, that being raised to the 6th, will just be x to the 6th, because the even power will get rid of that negative. So if I look at what we have, this is, because this negative sign in front, this is the negative of the function that we started with, negative f of x. So this shows that f is an odd function. And because it's an odd function, if we do an integral from negative a to positive a of an odd function, that's just going to be 0. So I didn't even need to do any antiderivatives. I just got to use the symmetry of this function to evaluate the area. All right, so I want to end this video with a question, which is, how would I know to try even and odd functions? Because in this video, I kind of set it up to say like, oh, by the way, if I have an even function or an odd function, and I have an integral from negative a to positive a, here's what happens. So we were already sort of thinking, oh, okay, maybe I'm going to use that even odd function trick once I got to this example. But how would I know if I didn't say to use the trick, that to think of that in the first place? So I want to give 2 tips. The first tip is, if the integral that you're working with, if our integral has the form where it goes from negative a to positive a, it's got to be a definite integral that goes from negative some value to the opposite of that, positive of whatever that number is, of some stuff, d, whatever the variable is, let's just say dx. Okay, the other way to know, the other sort of tip-off beyond just seeing that is like when that stuff that you're integrating, when that stuff, so let me highlight it. So when that stuff is either hard or maybe even impossible to integrate. So in this example that we did, that was actually the case. This function looks pretty hard to integrate. Like even with U-sub or whatever techniques that we have at this point, this is going to be very difficult to integrate. And that's a tip off that maybe there's some clever way to do this. And for this problem there was. It was to use even and odd functions. So in terms of our goals for this section, we finished our last goal, which was to do some harder examples.